Hello everyone, so today I'm going to show you how to solve these two problems, okay? So the question is 63, okay, you can read this, right? Okay, so the mass is 63 kilograms and the acceleration is 4.20 meter per second square. So they ask for what is the external force on him. So for this, you can just solve it like this. So it's the net force is equal to mass times acceleration. So you take the mass, which is 63, and then you multiply by the acceleration is 4.2 meter per second square. So you should get 4.2. You get 264.6 meter newtons. Okay, so the second problem, so say like if the sprinter, so here, so the question is, so the sprinter accelerates at a rate of 4.2 for 20 meters and then maintain that velocity for the remainder of 400 meter dash. What will his time for the acceleration? So the total distance is 100 meters, right? Okay, but for the first 20 meters, his accelerations is 4.2, and for the remaining 80 meters, we have to find his final velocity. Okay, so treat this as two different kinematics equations. Okay. So we're gonna work with this part first, okay? So there are two parts in total. So one. So write out everything you know. Okay? So let's say he start at the zero mark. So we'll put it at 0. So the final mark is like right here, which is 20 meters. And well, the runner is starting from rest, right? Yes, the runner starts from rest, so his initial velocity is 0. We don't know his final velocity. And for the time, let's just say he starts at 0 seconds. And we don't know the final time. Acceleration, we know it is 4.2. So just try out multiple equations. One equation is delta V equal delta TA. So VF minus VI equal, I just say TF times A. So your VI is already 0, so might as well just cross it out. So final velocity is equal to TF. You don't know it yet. 4.2. Okay, so that's what you get with these equations. So using another equation, which is this. Okay. So the total distance for this first part is 20 meters, and there's no initial velocity, remember? So just cross it out. So 1/2 4.2 t squared. So you can find time, the time he represents, the final time. So you'll get this 20 1/2 4.2. The answer for this, let me use my calculator. .09 seconds. Okay, so you'll put that in. Okay, so now you have the time. You can plug the final time back into here to find your final velocity. So Vf is equal to 3.09, 4.2. That'll give you 13 meters per second. Okay, so that means at this point right here, the velocity of the runner is 13 meters. Okay, so now we're going to solve for the second portion. So we'll do the table. Figure out everything you have. Okay, so let's just say you start at 0. You can say you start at 20 and end at 100 meters. But another way is say you start at 0 and end at 80. Treat this right here as 0, the starting point. So initial velocity is this, VI 13. And in the problem, they said that maintained the velocity for the remainder of the race. That means his velocity will be the same until he reached like his final points. So let's just say it starts at 0. You can say start at 3.09, and you can add up. But let's just say make it simple like this. So you don't know the final time, and because the velocity is constant, your acceleration is 0. Okay, so let's just use V. Don't use this equation V equal AT, because your acceleration is 0, so you're gonna get 0. So try using this one, VI delta T plus 1/2 AT squared. So your total distance is 80 meters. And your initial velocity is 13. T final plus 1/2. Okay, so at this point, just cross out this part because the acceleration is 0. So it will make the whole entire thing 0. So basically you already have your final time. That will give you 6.50. Okay, so yeah, you technically solved for it. So the question is, what will his time for the race? We just add them up. That will give you 9.24 seconds.